Hi everybody. Here I have taken a building frame, and on this building frame two lateral loads are acting. So our target is to determine approximately the reactions and moments at the base of the columns at a point A, B, C and D. And to do this, we will use portal method of analysis. So this portal method of analysis, it is actually used for analyzing fixed supported building frames, and which requires three assumptions. So let's see what are those. First assumptions: a hinge is placed at the center of each girder. How to do that? Like this. Because these hinges are assumed to be a point of zero moment. It is very important points. And the second assumptions also, a hinge is placed at the center of each column, and these hinge points are assumed to be a point of zero moment also. Third assumptions, at a given floor level, say this floor. So at a given floor we can say the shear at the interior column, I mean here and here, it is twice than at the exterior column hinges. So how it is? Let's say shear at exterior column, it is V. Then for inside column, of course it will be 2V. And for this floor, it will follow the same rules like this. Here V1, here it will be 2V1. This is third assumptions. How it comes? Since the frame is considered to be a superposition of portal, that is why if it is V here, here it will be 2V, here it will be 2V, because it is a superposition of portals. It is very important point to understand also. Now let's see how to solve this. So what we will do, we will take a section here. A section through the column hinges. And if we take section, it will yield the free body diagram of this top part. Free body diagram of this top part. So let's take this top part separately. Now this is the free body diagram. Here third assumptions regarding column shear applies. How? If we take summation of horizontal forces equal to 0, then surely we can write this 12 minus of V minus 2V minus 2V minus V equal to 0. Now solving this, we can find V equal to 2 kilonewton. Then we put here 2. So of course these two will be 4 kilonewton and 4 kilonewton. So in this free body diagram, already there is hinges at the girder as well as hinges at the column. I mean, it is at the center of the column. Here, center of the girder. And here we can see the shear. So it is third assumption. So all the assumptions are fulfilled for this free body diagram. So what we will do now? So using this all, results what we got here, as well the situations of this situation, what we can do, say we can now proceed to do one important things. We will dismember the frame at hinges. Suppose this is hinge, this is hinge. So we will dismember this part. As a general rule, always we start the analysis at the corner or at the joints where the horizontal load is applied. So surely we will start from here to determine the reactions at this point and at these points. So let's take that free body diagram, and once we have done this, we will also take out this one and next this one, then we'll do analysis for these joints, these segments. So there are 4 segments we are taking from this free body diagram. First we are taking K. These positions, if we look at, there will be horizontal and vertical reactions component at this point as well at this point. So how to get those? First we take here horizontal reaction component from here. It is 2. So let's bring that. Now we can go for vertical component, but before that we can find this very easily, because if we take summation of horizontal forces equal to 0, easily we can find this horizontal reaction components, that is K prime X. Easily we can find, because this right directions I took positive, so left direction it will be negative. So minus K prime X minus 2 plus 12 equal to 0, because this is plus. So K prime X equal to 10. So summing horizontal forces, we found this. Now similarly we can find this vertical reactions component. How it is? We have to take moment about these points. How to get that? Take the moments. Anti-clockwise positive. So this K double prime Y multiplied by 2.5, because we are taking moment about these points, minus of these 2 multiplied by these 2 equal to 4. So easily we can find K double prime Y equal to 1.6 kilonewton. So we are finding here this 1.6. Now this 1.6 we know. So there are 2 places we can see the vertical reactions components. So easily we can find it summing vertical forces equal to 0. Because this force minus of this, these reactions minus of these reactions equal to 0. So easily we can write K prime Y equal to 1.6 kilonewton. So we got it. So we are done for this K segment. Now let's go for the next segment, L. So this is L segment. In these positions, we must get horizontal and vertical reactions component. But to get this, we need to look at these points, K prime. So how we can get this? If we bring these segments. So let's bring this segment K. Then we find these two reactions component 10 and 1.6. So we can take this and put it in these positions. Surely we can write as this, but in opposite directions. So once we get this, so at these positions also we can put horizontal reactions component. It's very easy to get because L means here, so we can bring this 4 kilonewton at these positions. So let's put that. So once we get these two horizontal reactions component, easily we can find these positions horizontal reactions component. How to do that? Summing horizontal force is equal to 0. So here we find minus L prime x because this is this point. So we are taking x components. So minus L prime x minus of this 4 plus of 10 equal to 0. So L prime x equal to 6. So we got it. Now let's look at vertical components. These two are the vertical components. First we need to find this. So surely we have to take moment about these points. About these points means these forces multiplied by 2.5, but it will be positive because anti-clockwise. Minus of 4 into 2, here we have 4, so 4 multiplied by these two, plus of 1.6 multiplied by 2.5, so total is 5 because we are taking moment about these points. So we are done with these equations of equilibrium, and L double prime y equal to, at an end it will come 0. So surely we can put here 0. Once we get 0, so easily we know what will be the value for this because as we know this. But easy way to get the summation of vertical force is equal to 0. So we can write this L prime y upward, so positive, this is downward, negative, minus L double prime y, this is also downward, so minus 1.6, so L prime y equal to 1.6 kilonewton. So easily we got this reactions component which is vertical. So we are done for this L segment also. Now let's move for the M segments. So let's bring down M segments. What we'll do here? Same procedure we have to follow. We need to see what are the reactions component at this point. So we need to see these positions bringing this L segment. So let's bring L segments. So what are the reactions component here? 6, 1.6. So right away we can bring these two reactions component at these positions. So let's bring that. But opposite directions. So we are done here. Now at this position and this position we have to think of. So first of all we bring this 4 kilonewton. Already there is a shear force here, so we can bring this 4 here. So let's bring that. Now we need to find these horizontal reactions components. How to? Summing horizontal forces equal to 0, we get this. Because minus m prime x minus of 4 equal to, plus 6 equal to 0. So m prime x equal to 2 kilonewton. We are done. Now our target to get the vertical component of these two positions. So what you will do? These are the directions of vertical reactions. So let's find this first. So in this regard, we have to take moment about these points. And taking the moments, say m double prime y multiplied by 2.5 minus of 4 multiplied by these 2 plus of these 1.6 multiplied by 5, because we are taking moment about this point. So easily we can find m double prime y equal to 0. So let's put the 0 here. Now our target to find this vertical reactions component. So how to get that? Summing vertical force is equal to 0. So m prime y plus of m double prime y, both are upward, so we have to take plus. This is downward, so minus. So easily we can find m prime y equal to 1.6 kilonewton. So we are done here. Now let's move to the last segments, n. So let's bring that. Now same procedure we have to follow to know what are the reactions component at these points. So what we will do, we will bring these m segments to get this reactions component at this point. So bring that. Now what are the reactions component here? 2 and 1.6. So let's bring these two at these positions. We got it. Now we need to see what is the value for this horizontal reactions component. It will be nothing but only these two. So we can bring it. Done. Now our target is to find these vertical reactions components. How to get that? We can get it in two ways: taking moment about this point or summing vertical forces equal to 0. So let's first take the moment about these points. We can see how much it is coming. N double prime y multiplied by these 2.5 minus of these 2 multiplied by 2, we get n double prime y equal to 1.6 kilonewton. Without taking moments, we could do it very easily. As we know this, there are two forces. So surely summing vertical forces equal to 0, we could get it very easily, like n double prime y equal to 1.6 kilonewton. It was also possible to do very easy way. So we are done. For this free body diagram, there are segment K, L, M, N. So we did analysis to get the reactions at the hinge points. Now let's move for the next lower parts. So now we took the free body diagram, taking the sections at this point, I mean at this hinge line. So we took the sections here. So surely same procedure we have to follow, like if shear is here V1, so it will be 2V1, 2V1 and V1. This is third assumptions. Now we need to find V1. So what we will do, same procedure we have to follow, like total lateral forces are 18 plus 12. This is 30 minus of this V1 minus 2V1 minus 2V1 and minus V1, it will be equal to 0. Summation of horizontal forces equal to 0. So easily we can find V1 equal to 5 kilonewton. So we are sure now this is 5. So for these two in inner columns it will be 10 kilonewton, 10 kilonewton, and for outside column these hinge points shear will be 5 kilonewtons. Now our target is to take these segments P. So this segment, what we are doing, same procedure we have to follow to find the reactions component at this position and these positions. So for these positions, what we will do, because if we look at these positions here, this is the point, means at these positions. So let's bring that K segment to see what are the reactions component at this position. So I brought this. So if you look at what you can see here, 2 and 1.6. So of course these two components will come here. So let's bring that, but opposite in directions. So already brought 2 and 1.6. We can see here the same value, but opposite in directions. So we are done for these K segments. We can remove it. Now we need to bring here at these positions, what are the horizontal components? It will of course be V1. It is 5. So let's bring that. Now easily we can find these horizontal reactions component, summing horizontal forces equal to 0. So minus P prime X, that is the positions here we need to find, minus this P prime X, we are taking minus because right directions we took positive. So this minus, then minus 5, plus of 18, plus of 2 equal to 0. So P prime X we got here 15. So we are done with horizontal components. Now let's look at the vertical ones. So what we will do, we have to find first this one. To do this, we have to take moment about this point P prime, these positions P prime. So let's do that. So what are the forces we have to take in this scenario? Say P double prime Y, I mean this one, multiplied by 2.5 minus of 5 multiplied by these 2, then 1.6 multiplied by 2.5 because we are taking moment about these points, minus of these 2 multiplied by 2. So we are getting the equation of equilibrium like this. Then easily P double prime Y equal to 7.2, right we can write here 7.2 kilonewtons. So we got it. Now easily we can find it. How? Equation of equilibrium, summing vertical forces equal to 0. So P double prime, P single prime Y minus of P double prime Y plus of 1.6. So easily we can find P prime Y equal to 5.6 kilonewton. So we are putting that value here. So it means we are done for the P segments. Now let's move for Q. So for these positions and for these positions, reactions component, we have to bring the P segment, and for these positions reaction component, we have to bring the L segments. So let's bring this P segment first. So what are the components here? 15 and 5.6. These positions mean these positions. At these positions. So we can put the 15 and 5.6 but in opposite directions. So we are done. So we can remove this P segment. Now we can bring L segments. So how to do that? L segment, we got it. So we have to look at this point, because this point means this point. It means it will be here. So already I got here 4. Yeah, but opposite direction. But I don't need to put this because it is 0. So no need to put here anything. So remove this. Now, like other segments, we can put the value here, because easily we can take it from this value 2V1. So it will be V1 means 5, so 2V1 means it will be 10. So easily we can write here 10. Now summing horizontal forces, we can find Q prime x. So minus Q prime x, minus of 10, plus of 15, plus of 4. Easily we can find Q prime x equal to 9. So we got it. Now our target to find these two vertical reactions components. So let's first find this one. So how to? We have to take the moment about these points. So Q double prime Y multiplied by 2.5 minus of 10 into multiplied by 2, then plus of 5.6 multiplied by 5 minus of this 4 multiplied by 2. So this equation of equilibrium, it is of course equal to 0. So Q double prime Y, this one, we get 0. So put here 0. So once we get this, and already we know this 5.6, so easily we can find it, this vertical reactions component. How? Summing the vertical forces equal to 0, we find Q prime Y equal to 5.6 kilonewtons. So we are done with these Q segments. So let's move for R segments. So in this segment, first we look at these points. How to get this? Surely R segment is taken these from these 4 hinges. So surely we need to know these points. reactions component. So we have to take the segment Q. So let's bring that segment Q. So what are the components here? 9 and 5.6. So let's put that in these positions. So it is done, but in opposite directions. If you compare this, it is opposite in direction with same magnitude. Now we can remove this Q segment. Now our target to get these points, components. How to get this? Look at here to M segments. Then easily we can find this. So how to? We can bring M segments. So once we get M segment, we know what will be the horizontal reactions component. It is 4 and vertically it is 0. So vertically no need to put anything, only horizontal in opposite directions we provided here 4. So this M segment, it is done. We can remove it. Now our target to put here horizontal component, very easy. We have to look at here what are the shear values we had. 2v1, it means 10. So surely we can write here horizontal reactions component 10. So once we get this, our concentration for these points. How to get that? Summing horizontal forces equal to 0. Easily we can find r prime x, because this point is r prime. This one, it is 3 kilonewton. How we got this? We got minus r prime x minus of this 10 plus of 9, this one plus of 4, it is equal to 0. So r prime x equal to 3 kilonewton. We got it. So we are done with these points. Not yet, because still we have remaining these two reactions, I mean vertical reactions component. So what we will do? We have to find this. Same procedure we have to follow, taking moment about this point r double prime y multiplied by 2.5 minus of 10 multiplied by 2, 5.6 multiplied by 5, because we are taking moment about this point, force is here, and minus 4 in multiplied by 2, 4 is here, distance is 2 meters. So from about this point it will be 4 into 2. So easily we can get r double prime y equal to 0. So it is 0. So once we get 0, we already know this is 5.6. So easily we can find these vertical components, reactions component. How? Summing vertical forces equal to 0. So r prime y upward positive, this is upward positive, minus of 5.6 because this is downwards. So easily we can write r prime y equal to 5.6. So this will be the value for this reactions component. So we are done right now. It is okay. Now we can move for S. So how to do that? We need reactions component at these positions. So to find this, we must bring this R segment to get these positions, reactions component. So let's bring that R. So what are the values here? 3 and 5.6. Let's put these two values here. 3 and 5.6, but opposite direction. So we are done for these points. Now let's look at these points. So what it is? these points means we are here. So we need to bring these n segments. So this is the n segments. So here we can see 2 and 1.6. So surely we can put these components at these positions. So let's do that. Now our remaining at these points, here we need to see what are the horizontal reactions component here. Surely we know it is very easy to get because here already you can see it is V1. V1 means 5, so we can put here 5. Put that 5. So we are done. Now we have remaining these components. So how to get that? We can get it by taking moments about these points, say S double prime Y multiplied by 2.5 minus of 5 multiplied by 2 because we are taking moment about these points, then 1.6 multiplied by 2.5, again these two multiplied by these 2 meters. So equation of equilibrium we got, it is equal to 0. So S double prime Y equal to 7.2 kilonewtons. So we got it. We are done. Even I showed here, instead this procedure, without taking moments, we can find it also. How summing vertical forces equal to 0. Say S double prime Y, this is upward, positive. This is downward, negative. This is downward, negative. So if you write the vertical component, this equation of equilibrium, then S double prime Y equal to 7.2 kilonewtons. So we got. Now, what are the forces? I mean, these components, reactions component we got here. We will connect this with the support. We will transfer this with the support reactions. How to? Let's see that. Look at this 7.2, 0, 0, 7.2 we brought from previous slides. Now surely, as we know, these are the forces acting this direction, this direction, this direction, this direction. Surely there will be here also at support same magnitude. It will be working like this, 7.2, 0, 0, 7.2. Now here there is a horizontal reactions components. It is this one. At this position, it will be in these directions. Now, here it will be in opposite directions. So once we get this horizontal reactions component, then as well here at support we got horizontal component and the vertical components. Now what are the moments here? Moments will be nothing but these horizontal components, 5 multiplied by 2, so it will be 10. 10 multiplied by 2, it will be 20, here 20, here 10. So we got all the reactions in terms of horizontal component, vertical components, as well as moment. MA 10, MB 20, MC 20, MD 10. So I think we are done for this building frame to find the reactions and moments.